Compute the following limits without using L'Hopital rules. The limit of a function x squared minus 16 all over absolute value of x plus 4 as x approaches negative 4 from the left. So in this case, you need to be careful. The terms absolute x plus 4 here is either mean x plus 4 or negative x plus 4. So because the question asking for x approaches negative 4 from the left, then we use the negative sign, which is negative x plus 4. So in this case, this one will be 4 from the left. Okay, for the problem of limit as x approaches negative 4 from the left of x squared minus 16 all over x plus 4 absolute value, this will become the limit as x approaches negative 4 from the left of x squared or x minus 4 multiplied by x plus 4, which is the same thing, divided by, in this case, we use the negative 1, which is negative x plus 4. And as you can see, the x plus 4 can get cancelled with the other terms, with the other elements and the numerators. So the problem will simplify to becomes the limit of the function as x approaches negative 4 from the left of x minus 4. X minus 4. That will be the simplified function. So as you can see, and don't forget we need to divide it by negative 1. Yeah, from here we have a negative 1. So got to write down this is negative 1. So by doing substitution, as x approaches negative 4, so the equation become negative 4 minus 4 divided by negative 1 will simply be negative 8. Okay. So positive 8. That will be the answer for these questions. Next question, compute the following limits without using L'Hopital rules. The limit of e to the power of 2x minus e to the power of x all over e to the power of x minus 1 as x approaches 0. So to solve this problem, we can first try to simplify the questions. So the question will be simplified into e to the x. Let me just write down everything. E to the 2x minus e to the x divided by e to the x minus 1. This is same as take the common. In this case, the common element will be e to the power of x multiplied by e to the power of x minus 1. Now it becomes the same. All over e to the power of x minus 1. As you can see, the elements can get cancelled out one another between the numerator and the numerator, leaving behind only the limit of e to the x. So let me just simplify the problem. Limit as x approaches 0 of e to the x. By doing substitution, x approaches 0, then this is equals to e to the power of 0, which is equals to 1. Complete the following limits without using L'Hopital rules. What's the limit of x plus 2 sine x all over x as x approaches 0? This is quite a simple problem. The first thing is always try to simplify the equation itself. So in this case, we can rewrite in the form of, you can say that this is limit of x approaches 0 of x plus 2 sine x all over x is the same as limit of x approaches 0 of x divided by x equals to 1. Okay, and you can say x plus x, or sorry, x over x plus the limits x approaches 0 of 2 sin x all over x. So in this case, the limit of x over x equals to the limit of 1 as x approaches 0 plus the limit of x approaches 0 to sin x over x. And this is uh, the expression of sin x over x is always equals to 1. So this is equals to the limit of 2 times 1. So in this case, limit of 1 equals to 1 and the limit of 2 is equal to 2. Therefore, the overall, okay, limit of the function as x approaches 0 of x plus 2 sin x all over x is simply b. What's the limit of a function s square root of 9s squared plus 4s plus 7 all over 6s minus 2 as s approaches positive infinity. So for limit at infinity, we can always try to simplify the problem with the highest power by dividing the function with the highest power. So in this case, although the highest power seems to be s squared, remember s in this case is the variables, but the s squared is actually under the square root sign. So it's simply square root of s squared is simply s, right? So the highest power is actually s to the power of 1, which is simply s basically. So we can cancel all these the elements, simplify the problem with by dividing or by multiplying with 1 over s. So let me just write down. So in this case, limit as s approaches positive infinity of square root 9s squared plus 4s plus 7 all over 6s minus 2 can be same as multiplying them with 1 over s. Remember, this is s, not 5. 1 over s. So in here we will have limit of s x s to infinity of 1 over s. 1 over s multiplied by square root 9 s squared plus, or don't forget here there is a 4s plus 4s plus 7 all over 1 over s multiplied by 6s minus 2. So we try to bring the 1 over s inside the square root sign, so we can cancel the s inside the square root sign. So this will become the limit of s approaches positive infinity of square root 9 s squared over s squared, because the square root of, okay, the square root of 1 over s squared equals to 1 over s. So that's why you got square root of okay, and then plus 4s also divided by s squared plus 7 also divided by s squared, and all of this is under the square root sign. Remember, it's all of this divided by 6s, remember, multiplied by 1 over s, so this becomes 6s over s minus 2 over s. Let's try to simplify this again. S approaches positive infinity of square root of 9 plus 4 over s plus 7 over s square all over 6s become cancelled, so become 6 minus 2 over s. Substitute. Now we can substitute. Can try to substitute s equals to infinity. So the expression will become the limit of s approaches infinity of square root 9 plus 4 over infinity is 0 and 7 over infinity square is also 0. All of this divided by 6 minus 2 over infinity will become 0. So the question become limit of s approaches positive infinity of now only square root of 9 divided by 6. So in this case 3 over 6. Therefore the answer is half, 3 over 6.